Hello everyone. It's been a while since I've updated or done an update on the rally truck, but I've actually been making a lot of progress behind the scenes. Unfortunately, I haven't been able to show off all of that, and it's come at the price of not uploading some of my normal videos, but I do have some exciting builds coming up. I've managed to locate a BMX rear-wheel drive drifting car in the 1/24th scale, and that will be coming to the channel very, very shortly. It just depends on how the shipping is internationally. I suspect that'll probably be in about 2 weeks' time, so look forward to that. However, I actually considered this to be the more interesting project. So one of the things I've done is originally I had the wheels weighted with brass, and I realized I actually don't need this because this isn't a crawler. This is actually going to be a bit more of a trailblazer. So I've replaced that with the standard aluminium, I don't know what you call it, tubing on the inside that turns these into a beadlock. But I still have the brass ones available should I need it later. And I'm very, very tempted to see how this will actually crawl in the end, because if I take the shocks off and we look at the maximum amount of... if I can get that off. And we look at the maximum amount of droop we can get out of it, it's about that. So normally it's about that, and it goes all the way to that. And this will become important in a minute. The camera is a bit blurry, and that's due to technical limitations at the moment. I'm currently having some issues with my webcam, but as we can see, if I raise the chassis, I can get significantly more space underneath that. And that goes up by about another centimetre or so. So I think that gives us about 4 centimetres. Yeah, probably about 3 or 4 centimetres underneath the chassis. So when it's just sitting there, it should be about 2 centimetres or so. So let's just reattach the shocks for the moment and start diving into the package that arrived today. I was going to say I wasn't going to show all of the package, but I might show some additional bits. So let's see. Let's take a quick break from the rally truck. We'll come back to that in a sec. First things first, I had one of the new bodies arrive. So this is one of the LM models. It's a bit hard to tell on camera, and it doesn't show up well on camera, but that's actually a very, very dark blue, not a black. So I've had my eye on this. The quality is spectacular. The finish is like glass, and the silver details there just shine. But at the very least, I've got some extra LM wheels, so that came today. I also had another crawler body, so I actually ended up with the Toyota red model, which I wanted, and that is also very, very glossy as well. Very, very happy with that. I also had, if I grab it here, the SDR trike arrive. So this is a full scale 1/12, and it's probably not as relevant to the Mini Z stuff, but I enjoyed the B2B a lot, and I can't wait to get this out on the track. It has a very, very unique design here on the rear, where this side doesn't actually have a nut. It's got like a retainer, and then this side does have a nut, and you can actually tighten the diff up just by tightening that nut, which I really, really like. The workmanship on this is absolutely spectacular. I don't know if the chassis needs to be a bit looser, but we'll see when I drive it a bit more. So got to outfit that, and it'll be one of the few cars I've got that's actually brushless. Speaking of brushless, at least initially, this car is going to be brushless with the same motors as the little Orlandos, except rather than using the N20, I use the slightly longer N30 motor, which gives me a tiny bit more torque. And I'll be using a 1000 RPM motor in that, but I also have 2000 and a slightly lower one, so I can make it faster or slower as I feel the need. And if I find it doesn't have enough torque, or if I feel I can go up to a higher RPM, if I had a bit more torque, I might actually convert this to a dual motor. I've been playing around with where I can place some motors here to actually get it all working. I am waiting on Tiny 4x4, a package from them, because this is front and rear wheel drive steering, and I just need another front section to put on the back, and then we'll get much tighter turning circles. And there's servos for that, but we'll get into that in a moment. So this is most, if not all, of the electronics I'll be actually loading onto the body. And if we just check it on here, I actually put the stiffer springs on here, so we can see it just droops ever so slightly. So on the softer strings, the softer springs, it was more like that, which is almost bottoming it out. But if we have a look at this, actually just let me fix the focus on this. I'm not too happy with the autofocus. I think we're just going to have to live with that. So this is a full electronics package. When this was on this previously with the softer springs, it drooped a lot more, but I hardened it up, and there's still the possibility to add some more weight to it. I didn't want it to sit as high as possible. I actually do want it to droop a bit more, so even if there is nothing more to put on here, and the body will actually weigh a bit, I'll actually just weight it to get it probably in the midpoint on the suspension, because I do want it, when it goes over jumps, to have the wheels drop down a bit. The servos will do that as well, but we'll see how that goes. And I'll get more into the servos in a moment because they're somewhat special, and I'm still waiting on some parts of that. So let's take a look at the electronics packages and various things that arrived, and basically what makes up everything that's going into this chassis. So I'll get this stuff out of the way first. First we have 6 20-gram servos. Now these are all metal, and if I was doing it again for someone else, I'd definitely use the plastic ones to lighten everything. But we'll see how it goes with the final design. I've already found a way to redesign this front suspension, such that I only need 1 servo at the front and 1 servo at the back to make the car rise and lower. But basically what we'll do is have this here, and a servo there and there. Then the servo horn will come off to the side where the mounting point is here, and the servo will then be able to raise or lower the servo. So that maximum droop we saw before will actually be important, because we'll be able to rise and lower the car to actually go lower on the flats and go higher when we need to go over bumps. We also need a servo for steering, which actually just sits up the front here. So that's good. And then the other servos sit behind that. So all up, that's about 60 grams. Now, I have been playing around with battery choices, and you'll see why at the moment I'm working around these ones. So they're just a standard nanotech. This is a 550 milliamp one. I use this on my crawlers, including my previous GK24 pink Hummer, which you might see on my channel a bit, as well as the Kyosho 4x4s. I just wire this in where possible. So I'll actually have one either side, and that won't go below the chassis at all. That will be level with the bottom of the chassis, just so I've got the maximum amount of clearance on the bottom. One on either side, and then in the center will sit one of the new FlySky receivers. Now, I did spot this on their website about a month ago, and then by chance I was in RC Mart looking at something else and saw it. The reason I picked this receiver up, even though I've got a whole lot of these mini ones and a whole lot of them left over because I now use them micro receivers, is this is only 4 channels. Now, if you wire 2 of these together, they do become 8 channels, but then if you look at it, the footprint becomes larger than just a single receiver. So that's lined up on the edge there, and it still sticks over the end. So this is 8 channels plus a sensor channel, and that sensor channel, and it comes with the cables for that, allows you to wire it into the battery voltage, so you can get direct battery voltage feeds. Because if you're sitting this behind a BEC, you normally just see the regulated voltage, and you can't see when the voltage is dropping to determine if your battery is low. So this has a little sensor port that allows you to actively monitor that, which is really, really nice. But on this build, every single one of these servos is both high voltage, up to 2S, and programmable. And we'll be using the programmable features to actually make the servo not nearly as responsive, and actually dial some of the strength out, so that if it does take a big blow, it doesn't hold its position, but gives a little and acts a bit like suspension. So that should give me a bit more cushioning on the suspension, and because it's all programmable, I'll be able to dial that in or out. And this will actually be driven by a full, I want to say 50 megahertz processor. It might actually be 120 megahertz processor. So I'm actually building the firmware that will auto-level the vehicle both side to side in terms of roll and back and forward, and also allow you to change the height. And that's got a full accelerometer on board, and that's for another project I'm working on called Pace Notes, which will be part of this, which will act as effectively a co-driver. and tell you when a turn is coming up and give you pace notes like a rally driver. It's part of a much larger project that I still don't have much to show for it except for code, and I don't know how good people are at coding on here, but that may not mean a lot to a lot of people. So I'd rather have a working demo before I start showing it off, but I can answer questions on that. Cool, so we've got the servos, we've done the battery. We've talked a bit about this. It does do S-Bus and I-Bus, and I do need that because I feed one of these channels into my controller to get the 1 or 2 dials from the transmitter. So one or two of the, I can't really see it in the light, 1 or 2 of these and one of that to change the height and the tilt, all over one single cable, as well as allow me to do some other more advanced stuff like inject telemetry back to the transmitter. And in the end, I don't actually have one handy, do I? No. This will actually have FPV on board and be running the DJI FPV system, and also feeding telemetry back over the video stream, which will be a lot of fun. I am going to see if I can cram a GPS receiver on board here, but the big problem I have, and this is why I might end up going for a larger battery, is this is already chewing a significant amount of power with these servos. So each one of these servos at idled consumes about 250 milliamps, which is, funny enough, about what the motor draws on its own. So 250 milliamps times 6 is 1.5 amps. Each one of these is 550 milliamps, so 2 of these is just over 1 amp. So we're looking at 1.5 C draw, plus motor, plus lights. So that gets us close up to 2S, and I think the final output, once we add the DJI system, if I don't add a separate battery for that, we're looking at about 3S. But all said, I might just have a battery dedicated to just the DJI system and then just remove it as required. Awesome. So there's actually one other thing I want to talk about, because there's not a lot of reviews about this online, and that is the Tekken BXR brushed DC controller. Now, this is totally overblown for what I'm doing. This will do 40 amps, which with the brushed motors on the Mini Zs, they might draw maybe possibly 12 amp. So this is way, way, way over-spec'd. But it does have one feature I really badly wanted, and that is you'll see it's got 2 connectors here. One is for controlling the motor, and the other one is for controlling the drag brake. So the drag brake is what happens when you release the accelerator and how quickly it comes to a stall. And it's a bit hard to do with this because I've got the motor shaft swinging around. So it'll come in with low drag brake, it'll actually come in and just keep on coasting. With high drag brake, it'll almost come to a stop almost immediately. And that is actually a feature I want to be able to adjust on the fly. So that was one of the reasons why I picked this up. The other reason was I've got a lot of Tekken stuff, and this is actually designed for crawling. So I'm very interested to see what the low speed control is. I've had a lot of DC controllers for Mini Z scale stuff, and they tend to be all over the place with terms of quality. So it'll be very, very interesting to compare that and see how much granularity in the trigger I get at the low end, which on my best one is okay, but could be slightly better, because I want to be able to crawl this as slow as possible, and as I said, potentially use it as a crawler. Just get some loose rubber on the tire. There we go. Cool. The other actually funny thing about this BXR controller is that the cables that come with actually weigh more than the actual receiver itself. And I found it fits perfectly in the middle there. So it even can go inside the chassis if I really want it to. The other nice thing is it comes with a power button, which may not seem like a big win, but I've had to do too many builds now that don't have a actual physical toggle switch, and I'm not going to do that again. And the best bit is it's actually got 2 holes drilled in it, so it should be fairly easy to mount in using the existing holes on the system. So that will be really, really good. In fact, I might mold something to go around that. Okay, now I actually do want to show some progress I've made on the rally truck. And this may blow some people's minds. So just a disclaimer, I have done CAD work before, and I have done programming before and embedded software design and hardware design. I won't be rolling my own PCB at this point in time for this project, but I might later. So let's swap over to my desktop view. Do I want to swap it for, we'll leave it on that. That's just OBS capturing the top hand corner here, but we won't worry about that too much. So this is the chassis so far. And in fact, if I bring this back at the moment, so these are the battery bays that go on either side of the chassis, here and here. And then these are the mountings for the servos, like that. And it goes on like that. So one of the interesting things about these frame rails is they actually kick up at the ends here. So they're totally flat for about 10 centimeters there to there. Then they kick up by 2 millimeters, top of this to the bottom of the ends. It's about 7 mils in total, if you include the top of the frame rails. And so what happens is, you can see I've got this little nick here. So this part from here backwards sits in the middle of the frame there. And then the chassis, this centerpiece kicks in slightly to fit inside the frame in the middle here. And the servos, we then screw in from the sides, and then that holds the servos in place. So let's just render this image. These actually need to go back a bit and line up with that, but I've got some of the math wrong at the moment. And this is way too high up the top here. I need to go off and correct that. But this is what the final product should look like. And I've got a little bit here for the motor, has 2 cables coming up, and that will feed through that little gap in the chassis there. So this is what the interior of the truck is looking like. The downside for having servos on the back here is there's no really good way to hide it. So I did actually want to have a flatbed version, and then I found the suspension gets in the way from that. So you have to make holes in the flatbed for that, which is a shame, but there's not much you can do there. Unless I redo the rear suspension, which is possible. But then once I add the servos in, there's no helping it. So I'll just have to make it like a full Dakar truck and have a big body shell on the back here, which is fine. And then the 2 tires hanging off the end, and do all the stickers and everything, make it look really, really nice. So that's a CAD design for that. Now I'm using a very, very weird piece of CAD software where it's very much like programming, and allows me to do volumetric design. So you can see I've got a whole lot of constants here. So I can actually change the length. If I want to scale this up, I can just change these constants after doing some measurements and print out a much larger version. But this is basically what the frame is looking like at the moment. This math is getting a bit too complex for my liking. So I'm going to go off and fix this all up and simplify it, because I chose to do it in what was originally a simple way that got more complex the more parts I added. So yeah, for me at least, this is what CAD and CAM looks like. For others, they're probably using Fusion 360, although I saw that Fusion 360 removed some features, and there were features I was looking at using. So 4 and 5 axis milling, because I'm very, very tempted to go off and get down the track a milling machine, so I can actually custom fabricate these metal frame parts and parts like that. Because if you haven't guessed, I'm actually looking at getting into custom chassis design and mini Z scale hardware. And so this is the original project, and then I've got more things planned down the track, including electronic and sensor suites and a whole lot of telemetry from your mini Z cars to give you like G-forces and drift angle, and being able to display that on your phone and change like your lighting patterns and light kits from your mobile phone and that sort of thing as well. So getting there, a lot of fun features planned. Is there something else I was going to show you? I do have these. Oh no, this is just, I ended up pulling it in OpenSCAD, so that's not that important. So that's it. That's where I'm at with the rally truck, I should say. I'm pouring a lot of money into this. The final part selection will likely be significantly cheaper. I'm trying to work out where is the best place to spend the money, and that's not completely obvious until the design is finished. like that ESC is definitely not going to be in the final version, but I'm trying to see where the top end is compared to the bottom end, and then work out where I want to be on that spectrum. And I mean, for considering this as a prototype, I just want this to be literally the best I can build. So I'll just grab one of the servos. I did talk about earlier about only needing one servo in the front for the suspension. So if you go back to the design here, and I swap back to the camera desktop. Oh, that's the one I should have used. Full screen cam. That's the one I want. If I go back to this, what I can actually do is place a servo like that. I could go like that, but the problem with that is the more space I've got here, the better, because it allows me to put heavy things like a much larger battery in the middle there. And that's of more benefit rather than orientating this. But if I go 90 degrees on that like that, then I can have the one servo arm going in and having one servo arm control both wheels. So you won't get the tilt management, but until I finish the design and actually run the car, I don't know if tilt management is going to be worth it. It is nice that I could potentially go up on something like that, and as you can see the frame's slightly tilted, and then just compensate slightly and just tilt that in. That would allow you to go on uneven terrain a lot better. And I still don't know how I'm going to detect uneven terrain, whether or not I have sensors pointing down, determining your position and how far you are from the ground, or whether or not I use the G-forces and it stays at a set level, and then if you go into the air, it just pushes the wheels all the way down, just so you've got the maximum amount of droop and land on that. And even as it is, I'm going to have to put actual physical drop stoppers here just to prevent the metal-on-metal contact. So the final product is going to be, the final prototype is going to be magnificent, and then I'm going to work on making it cheap, because these GK24 frames are not cheap, and I don't need this configurability to change the frame rail length. So I haven't really quite determined if I'll be able to just make this in one metal piece and get that manufactured, or manufacture that myself, or if I make a plastic version and just 3D print them on demand, and then just buy the suspension set up separately, or the Orlando ones, and use that to build the final design. The advantage of that is I could actually retool this entire suspension setup and actually make the entire thing level. It would allow me to put the servos flat with the frame like that, and some other tricks, and really get the center of gravity down low, because that's the big thing with the Dakar trucks. So thanks for joining me. I hope this has been interesting. I will be blogging or video logging or whatever as its major steps. I'm more than willing to answer questions about techniques and everything, and the CAD and CAM software I use. If you're starting out, just use Fusion 360. I've got very, very bad reasons for using the workflow I do. But I'm quite experienced in that area, so it took me 5 minutes to get this set up and going and have this design up and running quite nicely. So, yep, so keep on building, and I'll see you later.